Think back to the mid-2000s. If you were doing serious business, you were typing on one of these. That distinct, tactile click of a physical keyboard was the ultimate status symbol in mobile tech. Then came 2007. A presentation in San Francisco introduced a flat slab of glass, and virtually overnight, the physical keyboard was rendered obsolete. The general consensus is that losing the smartphone war was a fatal blow. The brand was written off, relegated to the same graveyard as Blockbuster and Kodak. Intrigued, but while those heavy plastic phones disappeared from our pockets, the company behind them was actually undergoing a silent, total structural mutation. Which brings us to this financial projection, a claim that this supposedly dead company will see its stock surge 120% by 2026. This chart shows the surge relies on a three-part equation: the legacy BlackBerry brand, tied to UNECE, integrated with artificial intelligence. To figure out if these 2026 numbers are rooted in reality, we need to forensically dismantle this equation, variable by variable. The first variable is QNX. At its core, QNX is a real-time operating system, or RTOS. It's a type of software architecture engineered specifically to run mission-critical infrastructure without interruption. Look at the shield icon in the equation. When your personal laptop freezes, you just restart it. It's annoying but harmless. An RTOS, however, is deployed in environments where a software crash means catastrophic physical damage. It acts as an absolute safeguard. Take the anti-lock braking systems in modern vehicles. When a driver slams on the pedal at 70 miles per hour, the internal software must execute the command to pulse the brakes in exact guaranteed milliseconds. Or consider a neonatal intensive care unit. The digital monitors tracking a premature infant's vital signs cannot afford to buffer or lag while processing heart rate data. QNX isn't built to run consumer applications or web browsers. It serves as the mandatory, invisible software armor for life and death physical hardware. That brings us to the second variable, the AI gear. We are rapidly moving out of the era of strictly mechanical machines and into an age of intelligent, autonomous robotics. For an autonomous machine to navigate a city street, it has to constantly ingest a massive torrent of sensor data, instantly categorize pedestrians, and calculate safe pathways in real time. This creates a fatal vulnerability. If the operating system hesitates for even a fraction of a second while processing that heavy AI workload, the physical machine fails to stop in time. Standard operating systems manage data like a crowded intersection. They queue tasks based on priority, creating unpredictable latency during spikes in demand. A real-time operating system manages data like a dedicated express lane, guaranteeing immediate execution of commands, no matter how heavy the processing load gets. Bringing artificial intelligence out of the cloud and into heavy, moving physical machinery requires a processing environment that never blinks. This introduces the final piece of our equation, NVIDIA. They are the undisputed leaders in manufacturing the dense, complex silicon chips required to run AI models locally. But there's a massive engineering hurdle. You cannot simply bolt raw, supercomputing NVIDIA processors into a 2-ton vehicle without a control mechanism to keep it stable. NVIDIA supplies the raw brain power, but that brain needs an absolutely bulletproof central nervous system to safely translate its calculations into physical motion. This is why NVIDIA partners directly with the subject of our equation. QNX holds the highest possible safety certifications, making it the only platform fully trusted to manage NVIDIA's explosive processing power inside heavy machinery. By securing these safety certifications, the company has positioned itself as an inescapable toll bridge. To use raw NVIDIA chips, to drive a car, or run a factory, you must cross their software platform first. So then, why does the original financial chart pinpoint 2026? That specific year is the industry's targeted tipping point. It marks the window when next-generation automation, like fully autonomous vehicle fleets and smart factories, transitions out of limited testing phases and scales into mass production. This line graph visualizes the AI edge computing market. It inclines steadily, then spikes aggressively at the 2026 marker. As millions of machines deploy the QNX NVIDIA architecture, the company collects a licensing royalty for every unit, creating a compounding revenue stream. This 120% projection rests on the compounding royalties generated as these automated systems move into mass production. We started by looking at a piece of consumer hardware that the market left for dead. Today, the code written by that same company is currently installed in hundreds of millions of modern vehicles. Sometimes the most effective corporate pivots happen out of sight. They require stripping away flashy legacy hardware to build the foundational software utilities that other businesses rely on. BlackBerry didn't die in 2007. It abandoned the consumer market to build the operating system required for autonomous, intelligent physical machines.